Okay, it's working. All right, this lesson is on periodic functions. Shh. This is going to get us ready for taking our trig stuff and merging it with function stuff. But we're going to look at what periodic functions look like first. So periodic functions essentially will have a repeating pattern that's kind of wavy like this. So we're going to start looking at some waves, okay? And so we're going to start with some story problems. On the number 1, it says an automated robot transports building materials between 2 locations which are 5 kilometers apart. It takes the robot 2 hours to reach the materials and 2 hours to return, neglecting loading and unloading time, so we're not worried about the time it takes to do that. Draw a distance versus time graph that shows the robot performing 3 complete trips. Okay, so we're going to put time down here on the x-axis and distance over here. So the time is in hours, I guess I should put that, and the distance is in kilometers. So we're going to start at the origin at 0, 0. The robot hasn't gone anywhere, it hasn't moved anything. Okay, so it's transporting between 2 locations which are 5 kilometers apart, and it takes 2 hours to get there. So that means after 2 hours, it has gone 5 miles. So that gives us the point 25.
Wait, is it in kilometers?
It's in kilometers. Oh, wait, does it say miles? Yeah, it says kilometers.
You said miles?
I'm sorry. I said miles. So 2 hours, it's gone. So it went to the second location, and now it's got to come back. And so after 2 more hours, it's going to be back at its starting point at 0. It's back at its starting point. After 2 more hours, it's going to go out again and go the 5 miles again. After 2 hours, it's back. 2 hours, it goes out. 2 hours, it comes back. And what we're going to do is we're going to connect these this way. And it's a very sharp, jagged line, not so much like the waves we'll do next week. But it is a periodic function. So we can see how this repeats. Now, what we call these periodic, to talk about time periods. So we would say that the period for this function,
4 hours.
The period is how long it takes to get there and come back. And so Cameron's right, it is 4 hours. So 2 hours there and 2 hours back. So to complete a full cycle. Okay, so the period is 4 hours. And what we do with periodic functions is we often will put in what we call a midline. So midline is going to be halfway between the top and the bottom. So the bottom's 0, the top's at 5. What's halfway between 0 and 5? 2.5. So if we draw a little line across here at 2.5, that's going to be our midline. So our midline, we're going to make an equation for that line. It's y equals, we don't have any slopes, so the slope's 0. You can leave that off. And then it goes through at 2.5. So y equals 2.5 is where that midline would be. And then we have another number called the amplitude. And I think I have a place to define these all down there. The amplitude is the distance between the midline and the top, or the midline and the bottom. It's half the distance between the top and bottom. And so the amplitude would be 2.5. Okay. And so this is going to help us later when we're writing equations for periodic functions. This will give us the information that we need to do that. We're not quite there yet. We're just kind of getting the basics of what a periodic function is. Okay, so let's look at number 2. Scooting this up. So suppose you're riding a Ferris wheel. The maximum height you attain is 16 meters, and the minimum height is 0. So basically, they're considering where you go down at the bottom for that to just be 0. You're probably a little off the ground, but they're just not worrying about that. And then the top is going to be 16 meters. The time it takes you to make one cycle, so go all the way around, one loop, is about 6 minutes. And I apologize, there's typos on this all over. So that the AO but is actually supposed to be about. Sorry. AO but. Draw a line which represents the scenario if you start with a height of 0 meters. So we're starting in the ground. We just got on a Ferris wheel. It takes 6 minutes to do the whole cycle. So that's to go up and down. So in 6 minutes, I guess I should actually label this. This would be my time in minutes down here. I know in 6 minutes I'm going to be back on the ground. And then over here we'll put the height in meters. So our maximum height is 16 meters, and that will be in the middle of my cycle. So it's going to take me 6 minutes to go all the way around. That means in 3 minutes, halfway will be at the top, which is 16. So it's going to look like that. And we can't put another full cycle, but in 3 minutes, I could go ahead and put that it would be up here, and you could kind of try to show where that's going to go next to just continue the pattern. It's periodic. So every 6 minutes, it's going to repeat. So I would say that the period on this is 6 minutes. The midline, where would my midline go? It goes from 0 to 16. So you're right, halfway is going to be 8. So my midline, remember we're writing an equation. It has 0 slope. So I'd have, you could write y equals 0x. I just leave that out. And then you'd have plus 8, so it'd be 8. But you have to have the y equals because it is the equation of that line. And then the amplitude is the distance between that midline and the top or the midline and the bottom, basically half the total distance. And so that would also be 8. These are not always the same number. Later on, we're going to have things that don't start at 0. You'll see some of those on the next page. So let's formally talk about period, midline, and amplitude. So period is the cycle length. And usually in real life, it's going to be time. It's going to be seconds, minutes, hours. And an abbreviation for it, they sometimes will use a capital T, which is just like time. Midline is a horizontal line halfway between the maximum and minimum points. So we've talked about maxes and mins. You have maxes and mins here. Your midline is going to be a horizontal line halfway up between the max and the min. And then the amplitude is half the distance between your max and min points, which we've already looked at a little bit. Scoop that up. Okay, so here is a trig function, actually. We're going to talk about exactly how these happen later, but I just want you to think of this as a periodic function. Something is cycling. This could be a sound wave. This could be, I'm trying to think of something else that makes waves.
Jet.
Light waves, sound waves. It could be the vibration from a jet engine. It could be all kinds of things. We don't know what it is. They didn't label it or give us a problem. We're just going to study the amplitude, period, and midline. So this one does not start at 0, 0. This is kind of slid down a little bit. So my maximum's at 2. My minimum's at -6. The first thing I want to talk about is the period. There's a couple of ways that you can study this. You can go from the max to the max or min to min, but these are not on exact points, and that can be difficult. Another way to do it is look at where it crosses the y-axis. So it's crossing the y-axis right here at -2. And I can see that it's going up, it's coming down, and it's coming back to this point, and that's where it's going to start over. So that distance from here to here, if I look at my labels, it says that that's pi over 2. You're going to see lots of pi's and radians with these. And so that distance is pi over 2, and then it does another one in the next pi over 2, and then the next pi over 2. So we're going to say that the period for this is pi over 2. And you will see lots of pi's on here. That's just how they're going to label it. So you might see pi over 2s and pi over 4s and pi over 6s and all of that radian stuff that we've talked about. And sometimes they'll use regular angles. Our x-axis is going to have angles. Sometimes they'll put degrees there, but usually it's pi's. All right, so let's do the midline. So I've kind of marked the midline a little bit here. Halfway between -6 and 2 is going to go right here. Just make sure you've got the same distance up to the max as you do down to the min. So there's my midline, and that's going through at -2. So my midline, the equation is going to be y equals -2. And then the amplitude is the distance from that midline to the top or midline to the bottom. So my amplitude would be 4, because you could just count 1, 2, 3, 4. Down 1, 2, 3, 4. Be careful, because sometimes they will change the scale on this and they'll go by 2s or 10s, but I can tell this one's just going by 1s, so I just counted the boxes. Okay, let's try some more. This will go pretty quickly now that we know what we're doing. So on number 4, it just is find the period and amplitude of the graph, give the equation of the midline, just what we've been doing. So I like to start with the period part of this. From the top to the top you could kind of figure out, but I've got this weird negative 3 pi over 2 and pi over 2. I'd have to add those. So this is another one where maybe I'll just start here. Okay, so I'm going to start here. It's going to go up. It's going to go down. It comes over here, and it's going to start over after this distance. So this distance from here to here is 2 pi, if I'm just reading it off of here. Starting from 0 is always kind of nice. So that's 2 pi. So my period, or let's abbreviate that with that capital T. So the period is 2 pi. And I'll just make a note for people who need these that means period. Okay. So where's the midline going to go?
Ooh.
So we're chopping it in half from top to bottom.
3.
So it looks like 3. So the midline is going to be y equals 3. Box my answers here. And then what is my amplitude? 4, because from here to the top it's 4. From here to the bottom it's 4. And so I'm going to use amp to abbreviate amplitude and just say that that's 4. Okay? But just be careful. I don't think there's any in the examples, but they could number these differently, so you just always want to pay attention to your scale.
Don't change it yet. 'Cause
I won't. I'm just going to leave it and come
I
on.
was writing on the wrong one.
Oh.
You screwed me up.
Okay. Yeah. We just did 4. Now we're going to do 5. Okay, so it says find, it's all the same directions. Period, amplitude, equation of the midline. So for this one, I'm just going to start from 0 again from here. It's going to go up, down, and then comes back and it repeats here. So the period on this one, the way that it's labeled, is 4 pi. So they did change the scale on this one. And just to show you, going back this direction, this is also 4 pi. It starts over every 4 pi radians. And so the period is 4 pi on that one. So the midline, if I cut this in half, would be right here, -5. So that's y equals -5. Got to have the y equals because it's the equation of a line. And then what's the amplitude?
2.
2. Good. From the midline to the top is 2. From the midline to the bottom is 2. Good. All right. They're going to get a little different on 6 and 7, just with how they're oriented with the 0 line and everything. So on number 6, if I start here at 0, this is actually, they've got that minimum point here on the y-axis instead of being somewhere in the middle. That's okay. We just think of it as going all the way up and coming back down and where it's starting over. So it's going to start over, it looks like every pi radians. That's pi, that's pi. So our period is pi. So even though they started kind of at the bottom of the cycle instead of in the middle like the other ones did, it's fine. And just so you know, if I measured between maxima or minima, those would also be pi. So you can measure it in lots of places. Anyway. All right, so the period is pi. Where's the midline going to go? At 4. Good, because I would chop it in half and leave us 3 above and 3 below.
3.
So the midline, I know, I just gave you 2 answers. So the midline is y equals 4, and then the amplitude then would be 3, because we just chopped it into 3 above and 3 below. Alrighty, scoot this over. Number 7. This one's tricky because this wave has been spread out. If this were a sound wave, this would be a very low-pitched sound because they've spread out the wavelength. And so we're going to have to guesstimate a little bit. So I'm getting half. This is going to be half of my period from here to here because that's my high point to my low point. And then I'm going to have to figure out where is it going to come back and start over. So if we're looking at it, this is pi, there's 2 pi, and it looks to me like it's going to hit again when it hits about 3 pi. You guys agree with that? Another way you could think of this, if this is the halfway point, 3 halves is the same thing as 1 1/2. So you could think of that as 1 1/2 pi. So I have 1 1/2 pi, another 1 1/2. That comes up to 3. So the period is going to be 3 pi. So you might have to kind of guesstimate a little bit where that's going to go. And you should be able to figure it out using math and get it exact. Okay, so the equation of the midline. Where's the midline going to go?
You should.
Right here, right?
That's I know.
So that's going to be y equals 1. So that's my midline.
2.
And then the amplitude is 2. Okay? So that's a weird one. You have to kind of figure it out. Oh, another way you could figure out the period on this one, as I was talking about, okay, this is the halfway point, and that's like 1 1/2 pi this way. You could also go this way, and that's 1 1/2 pi, and you could think of it going from here to here and completing a complete wave and add that up to get 3. That's another way you could think about that. Those are tricky, but using some math and logic, you can come up with the 3 pi. Okay, so let's look at another one. So on this one, they've given us the middle of the cycle here, and we're going down and up, but then we would actually have to complete the wave over here. So this is half of my period, which is 1 pi. So it makes sense that to complete it and start over, I would need another pi, and then down here, that would be about 2 pi. So my period would be 2 pi. Or you could measure it over to here. This line's kind of missing. This is negative pi, so I'd have pi this direction and pi that direction. You could add it up and get 2 pi. The midline would be right here at 6. So y equals 6 is the midline. And then the amplitude is 3. Okay, so I'm going to leave number 9 as the practice problem. I think some people have already done it. And that's where we're going to stop.